Hello everyone, welcome to watch our third presentation. After demonstration of the components and microstructures and investigation of the effect between microstructures and rheology in the first and second video, today we are going to talk about the actual production performance and how it is related with microstructure and rheology. In this video, we will firstly define the modes of product usage and custom perception of performance. Then we will design some simple tests to quantify the performance of Nutella from spreadability and mouthfeel. At the same time, the relevance of microstructure or rheology to these performances will be analyzed and demonstrated. Nutella as a chocolate sauce is obvious to be eaten by the customer, so its taste and mouthfeel are important as the product performance that should be invested in this video. Well, before put it into the mouth, the performance of Nutella mainly is to spread out on the bread or some other foods. So the spreadability of Nutella is the second significant performance.
Spreadability is a very subjective textural attribute of a material, and all materials will have a specific targets for spreadability acceptance. Spreadable foods such as Nutella hazelnut spreads are classified as elastoplastic materials. They must flow easily when deformed, but they must not flow under their own weight as liquid does. We demonstrate the spreadability of different products. Spreadability is a subjective term related to how easy a sample is uniformly distributed over a surface. As shown in the video, we can see the spread lengths of different products, which means hazelnut spread has the most significant spreadability. The crunchy hazelnut spread ranks second, and the American mustard has the lowest spreadability. Let's compare the sample 1 and sample 2. The hazelnut particle size of the sample 2 is larger than sample 1. It may be inferred that the dimension of hazelnut particles in the spread could be related to the spreadability. The smaller the size of the particles, the higher the spreadability of the spreads. Rheological behavior is determined by the particle size, particle shape, particle distribution, and compounds. The viscosity and performance change by adding the additives with sexotropy properties, making the product easy to spread in. Dalbert studied the spreadability of certain commercial foods by means of the WAM method and found that it was strongly related to the yield stress and yield strain of the samples. These foods have a common functionality. They need a certain degree of stress for adequate spreading and deformation. Once this stress is achieved, the material displays irrecoverable deformation. The yield stress has been linked with quality and consumer acceptance of the food product. Yield point of the spreadable food provides manufacturer with another parameter for quality improvement and control.
We also test the mouthfeel of Nutella and the Kraft's hazelnut spread respectively. We can feel the smooth texture and strong hazelnut flavor of Nutella, but for the other one, we can taste the obvious hazelnut particles. The characteristic flavor of hazelnut spreads has to be developed in several process steps. During the process, the components are mixed and refined to obtain desired rheological properties for final defined product texture. Most of the solid ingredients are about 1 mm or more in diameter. The tongue will detect particles larger than 0.03 mm, especially the chocolate particles will appear to be gritty. That's why the mouthfeel of Kraft's hazelnut spreads is not smooth. But for Nutella, milling produces a lot of very fine particles of less than 0.005 mm in size. In addition, relatively high content of fat means easier flow of the fluid, because of the better capacity of carrying all molecules to spread and distribute evenly. In this way, it shows the smooth texture.
In Nutella spreads, there are lots of tiny particles contribute to great interactions and make Nutella high viscosity. However, in Kraft's chocolate spreads, big hazelnut particles seen in bottle make it crunchy. When heating both spreads for a while, it is easier to stir in the Kraft spreads than Nutella spreads because the extent of big hazelnut particles can reduce the interactions between particles to make it less viscosity. For manufacture, temperature should be considered when dispersing Nutella into bottle. At high temperature, viscosity is low for easy flow, therefore Nutella can be easily bottled. When temperature decreases, Nutella will present high viscosity for storage and usage. In the video, we compare the performances of Nutella with other products. The viscosity and the performance change by adding the additives with citrope protein, making the product easy to spreading. In addition, due to the existence of oil and many tiny particles, which size is less than 0.005 mm, Nutella has a smoothie texture. Temperature can be enhanced to lower the viscosity for easy bottling.